Okay, today's lesson is called the Pythagorean identity. The way it works is basically it's the application of the Pythagorean theorem with the unit circle. So as you know, when you draw your angle, the terminal side basically can create a right triangle on the unit circle, with one leg being cosine of the angle and the other leg is sine of the angle. In this case, it's the angle A. So if you apply the Pythagorean theorem to this, you get sine A squared, or sine squared A, plus cosine squared A equals 1 squared, which is just 1. So this, ladies and gentlemen, is the essence of today's lesson right here. Sine squared A plus cosine squared A equals 1. All right, and then there's two other identities that are basically derived from the fundamental identity. In this case, you want to divide each term by sine squared A. So, as you can see, sine squared A divided by sine squared A is 1. Cosine squared A divided by sine squared A is cotangent squared A. And 1 over sine squared A is cosecant squared A. So this would be your other identity, your other Pythagorean identity. This is the second one. The third one is derived by dividing each term by cosine squared A. And in this case, you end up with tangent squared A. Cosine squared A divided by cosine squared A is 1. And 1 over cosine squared A is secant squared A. So this is the third and final Pythagorean identity that we will learn today. Let's take a look at example 1. So here we have sine x minus cosine x all squared. So what I like to do first is just write it out in expanded notation. Sine x minus cosine x times sine x minus cosine x. So we have to FOIL. And sine x, first term, sine x times sine x is sine squared x. The outer terms, sine x times negative cosine x, is negative sine x cosine x. The inner term gives you the same exact product. And the last terms, negative cosine x times negative cosine x, is positive cosine squared x. Okay, so when we put all this together, just as we normally do when we FOIL, we have to combine any like terms. And normally, it's the middle two terms, the O and the I. So when you combine them, you end up with negative 2 sine x cosine x. The first and the last go here and here. And you should recognize that the first term and the last term create one of our Pythagorean identities, actually the fundamental one. So let's go ahead and relocate cosine squared x right next to sine squared x, and together they become 1. Final answer is 1 minus 2 sine x cosine. Sage and scribe number 1. So first thing you want to do is rewrite it as sine and cosine. So this becomes 1 over cosine squared x, and this becomes 1 over sine squared x. We need a common denominator. So we're going to multiply the denominators times each other, basically. But we can't forget to multiply the numerators. So once we multiply both sides, we end up with sine squared x plus cosine squared x all over the common denominator of sine squared x cosine squared x. And the numerator is the only one that gets simplified to 1, because that is the fundamental Pythagorean identity. Number 2, first thing you want to do is find a common denominator. So we multiply both the numerator and denominator by sine A, and that gives us sine squared A plus cosine squared A all over sine of A. And you should recognize that the numerator, once again, results in 1, because that's the Pythagorean identity, and 1 over sine A is cosecant A. Number 3, so here we basically just have to group the first two terms together, and that is the Pythagorean identity of 1 minus b squared, which you should recognize is a difference of squares. So the answer is 3. 1 plus b times 1 minus b. Finally, number 4. You must recognize the Pythagorean identity in the numerator as 1. The denominator is 1 minus sine squared theta, which you should recognize as cosine squared theta, because if sine squared theta plus cosine squared theta equals 1, then if you subtract sine squared theta from both sides, you end up with 1 minus sine squared theta equals cosine squared theta. And then you apply the reciprocal identity and you end up with secant squared theta. Good luck to you.